Welcome to Cognito Key. Have you ever heard of something that's incredibly powerful but can't even get started on its own? It sounds kind of crazy, right? Well, today we're diving into a real engineering paradox, the synchronous motor. This is the motor that literally cannot start itself.
Yeah, it's a real head scratcher, isn't it? How can a machine be this precise, this powerful, and maintain a perfectly constant speed, but at the same time, it's completely helpless at the starting line? That's the big paradox we're going to crack open today.
So here's our game plan to solve this mystery. First, we'll tackle the constant speed paradox. Then we're going to peek inside the motor to meet the key players. After that, we'll get into the real drama, the magnetic conflict that stops it cold. Then we'll reveal the very clever trick that gets it moving. And finally, you'll see why this weird flaw is actually its greatest strength.
All right, let's dive right in. The constant speed paradox. So what makes a synchronous motor? Well, synchronous. It's that it runs at one speed, and one speed only. We call this its synchronous speed. Its entire job is to take electrical energy and turn it into perfectly consistent, super steady mechanical motion.
Okay, so to really get why it has this starting problem, we've got to look under the hood. It all boils down to the relationship between two main parts, two key players inside the motor. So meet our two main characters, the stator and the rotor. The stator, as the name kind of suggests, is stationary. It doesn't move, and it runs on an AC or alternating current supply. Then you've got the rotor, which is the part that, you guessed it, rotates, and it runs on a DC or direct current supply. And that right there, that fundamental difference between AC and DC power, that is the secret to this whole mystery. Let's zoom in on the stator first. This is the fixed outer shell of the motor. Now, when you feed it that AC power, something really cool happens. It creates a rotating magnetic field. I want you to picture its north and south poles, not just sitting there, but constantly spinning around, like they're chasing each other along the inside of the motor.
And what about its partner, the rotor? Well, this is the part that actually does the spinning. But it's powered by a DC supply, which means the current only flows one way. Because of that, its magnetic field is totally fixed. It has one north pole and one south pole, and they are locked in place. They never, ever change.
Okay, so you can probably see where this is going, right? This is where the big problem starts, the magnetic conflict. You've got the stator's magnetic field doing this constant dance, spinning around and around. And then you have the rotor's magnetic field just standing still. So what happens when you try to introduce them from a dead stop? Well, they just don't get along. Let's really break this down. Picture this. The stator's north pole comes spinning around and sees the rotor's south pole. For a split second, there's attraction. Opposites attract, right? But before the rotor can even begin to move, that AC supply flips. The stator's pole instantly becomes south, and now it repels the rotor's south pole. This push-pull happens so incredibly fast that the poor rotor is just stuck, vibrating back and forth, completely trapped in one spot. You know, the source material puts it perfectly. It says the rotor attracts for the first half cycle and repels for the second half cycle. It's basically caught in this perfect magnetic tug-of-war. And that, right there, is exactly why a synchronous motor is not self-starting. So, if it can't start itself, how on earth do we get it going? This is where the really clever part comes in, what we're calling the art of the start. The whole trick is to give the motor a little helping hand, just enough to achieve that perfect magnetic lock. So here's the sequence. It's pretty ingenious. Step 1, you use another motor called a prime mover to give the rotor a push. Step 2, you get that rotor spinning up to the exact same speed as the stator's magnetic field. And step 3, this is crucial, only then do you switch on the DC power to the rotor, giving it fixed north and south poles. And in that one perfect moment, they just lock together. It's like a key fitting into a spinning lock. The rotor's poles are now caught by the stator's rotating poles, and it's off and running all by itself. And once that magnetic lock happens, you don't need the prime mover anymore. You can just switch it off. The rotor is now being pulled along by the stator's field, spinning at the exact same constant speed. They are perfectly synchronized. Now, I know what you might be thinking. That sounds like a whole lot of work just to get a motor started, right? But believe it or not, this complicated little startup dance is exactly what gives this motor its amazing superpowers. So let's quickly go over its main features. Number 1, and this is the big one, its speed is absolutely rock-solid constant. It does not matter what kind of load you put on it.
Number 2, as we've just seen, it's not self-starting. And number 3, it has some really cool electrical properties that let it run super efficiently and even help stabilize entire power grids.
So where do you actually need this kind of perfect, unwavering speed? Well, think about really critical applications, like in power plants or hydroelectric stations. If the generator's speed wobbles even a tiny bit, you could mess up the whole electrical grid. Or imagine a textile mill where thousands of threads are being woven together. If the motor speed changes, you'd end up with a tangled mess instead of perfect fabric. In these places, constant speed isn't just a nice to have, it's absolutely essential.
So, I'll leave you with this question. Now that you know the secret of the synchronous motor, this one major flaw that actually leads to its greatest strength, where else do you think you could use a motor that absolutely demands perfect, unchanging speed? Let that one sink in. Hey, if you enjoyed cracking this puzzle with us, do us a huge favor and hit that like button, share this video, and of course, subscribe to Cognito Key for more deep dives just like this one. Thanks so much for watching.